a linear equation in the variables x1 through xn is an equation that can be written in the form a1 x1 plus dot 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 plus an xn equals b, where a1 through an and b are all constant. So are all constant. We call a1 through an, we call those the coefficients, and we call b the constant term. Some examples. (2x minus 5y equals 10 is linear. R plus 1/2 s equals 0.5 t minus 2 is linear. And that's because I can bring this 0.5 t over to the left side, and then I would have a linear equation in this form, which is in the variables r, s, and t. X equals 0 is also a linear equation. And x1 minus root 2 x2 minus sine of pi over 2 times x3 equals 0. So even though there's a sign in here, even though there's this sign, since the x3 is not inside of the sign, and so in other words, sine of pi over 2, and that's a constant, that means that this thing is linear. You'll also note that sine of pi over 2 is 1, but whatever. On the other hand, so non-linear, xy plus z equals 1 is not linear, and that's because we have these x and the y here multiplying each other. X squared plus y squared equals 2. That's also not linear because of the squares. Sine of x equals 0 is not linear because the x is inside of the sign. 2 to the y plus z equals 16 is not linear because we have this y up here. A solution to the linear equation up here is a vector. Let's call it s1 dot 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 sn, such that the equation is true when we substitute x1 equals s1 dot 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 xn equals sn into it. So for instance, 10, 2 is a solution to 2x minus 5y equals 10. Let's move the screen up a little bit more. Voila. In two unknowns, a linear equation looks like ax plus by equals c. Now you might look at this and think, well, where have we seen this already? This is the general form. This is the general form of a line in R2. Something I want you to notice, and this will become important later, is that the parametric form has one parameter. Now what happens in three unknowns? Well, then we get ax plus by plus cz equals d. And this should also seem familiar because this is the general form. This is the general form of the equation for a plane in R3. Put an exclamation point because it's very exciting. Yay. And also notice that the parametric form here has two parameters. We can continue the pattern to look at what happens with n unknowns. Here we just get our general equation for a linear equation. There is a technical name for what you get, but we're not going to use it in this course, so I'm not going to mention it. But the thing I want you to notice is that it will have n minus 1 parameters in parametric form. Finally, we get to the definition of systems of linear equations. So let me just move everything up. That was quick. Definition. A system of linear equations is a finite set of linear equations just put a little twiddly squiggle thing underneath here. It's a finite set of linear equations, each with the same variables. Each with the same variables. Note that when I say the same variables, some variables might be missing from one or more equations, but we want to think of them all as having the same set of variables. Let me put a little dot over here, another dot here, because I also want to say what a solution is. A solution to such a system is a vector that satisfies all the equations. Satisfies all the equations in the system, not in the entire history of the universe. And finally, the solution set of the system of linear equations is the set of all solutions. Solution only has one L. Solutions of the system. X plus y equals 2 minus x plus y equals 4. Another example. x plus y minus 3z, z equals 10x minus 2z equals 0, y plus z equals 1. So when I said that it's all right if variables are missing, but we're still thinking of them, we're really thinking of, although there's no y explicitly here, I'm really thinking of a plus 0y here, and here 0x plus there.